of the property. And the DTI, it's also quite important because it's also a ratio, but between the monthly debt of the professor over the monthly income of the professor. Let's go ahead. After we can find the rate, the maturity date, the first payment date, we can go to the next slide. The next slide, so we are at time t plus k. We know the behavior of the professor during this time with the performance data that we have. The long sequence number, what is the long sequence number in our analysis? Is a number associated to each client. So it will be different from each client from another. And the default is our dependent variable, as I say, the binary variable. And it will associate the number 0 if the person does not default. So if he pays regularly his obligation. And the number 1 if the person has defaulted during that time. And the long grid, as I said before, we know everything about the professor. We know if he has paid, the frequency of payments. So here we can find a letter like C, L, but also number 1, 2, 3. What do they mean? The C letter is it means that the professor pays regularly his obligation, so he's okay. The letter L means that the professor obtained refinancing in order to pay the loan. So we can find, after the first L, we always find all the other L, because the professor refinanced himself in order to pay his obligation. And after that, we can find also the number. The numbers represent the status of delinquency. So remember, as I said before, defaulted is considered a person after a status of delinquency of 60 days. So the number 1, we will find the number 1 after a status of delinquency between 30 and 59 days. So it's okay. The number 2 is from 60 to 89 days of delinquency. So you are defaulted after number 2, and this way also number 3, number 4, number 6. So we can have a look. After number 2, you have always the number 1. So you are always defaulted. So okay, you can go to the next slide. Last thing to say, talking about the data set, is how did we cover the missing data? For covering them, we followed different steps, 3 different steps. The first one, firstly, we thought to cover this missing data using the average of all the regressors. So creating this model, covering the missing data with the average of all the regressors. But we understood that it was a bad model, so the output was a bad model. After that, okay, so we changed our mind, and the second step was looking also at some graph like this, and some table to represent this missing data as approximately a normal distribution. We can see, looking at the skewness and the kurtosis, a normal distribution has to be a skewness equal to 0 and a kurtosis equal to 3. And the mean has to be equal to the median. In this model is approximately a normal distribution, so we thought to represent this missing data with approximately normal distribution adjusted for kurtosis and skewness using their mid polynomials. But it was a bad model too. So we changed again our mind and we cut this data. In particular, we delayed the long sequence number of the client who missed for some important variables, like I said before, credit score, LTV. We delayed this. And this situation led us to have a good level of K-Smirnov test, which is the test which tells us, okay, you did a good model, okay, you didn't have a good model. So it's a test which tests the efficiency of the model we created. After explaining the data set, My colleague will talk about the